Hello dear students. So today we are going to learn about some important naming reaction which are going to be very important for your GPAT as well as your NIPER exams. So I will upload this video onto the YouTube, so you can watch this video from the YouTube, and you can learn about some important naming reaction. Some part I will take, and some other naming reaction will be taken by the Payam sir. So first, if we start, the first naming reaction, which is the most frequent question which are asked from, is Bachmann rearrangement. So simply what Bachmann rearrangement involve is that in Bachmann rearrangement, first the keton will react with the hydroxylamine, which is NH2OH you can say, and it will gives you a ketoxime. It will gives you a ketoxime. Now this ketoxime undergoes rearrangement reaction. Here it is OH, not H. So it's a ketoxime. Now this ketoxime group will undergo rearrangement in presence of the acid. So acid we denote as H plus, and it will give you a substituted amide. So it's look like this. This is what we called as substituted amide. Okay, so simply what happens in case of Bachmann rearrangement is that first the keton will react with the hydroxylamine group, and it will gives you a oxime, or particularly as it is formed from the keton, so it's called as ketoxime. If it was formed from the you can say aldehyde, then it will called as aldoxime. Okay, so it is called as ketoxime. And very important thing, one of the most important thing, if you observe here, so here there is a possibility of geometrical isomerism, kind of a syn and anti. Okay, so the group which is anti to the OH, okay, the group which is anti to the OH will rearrange, because here the rearrangement take place here in this step. Okay, here in this step rearrangement okay, rearrangement take place. So the group which is anti to the OH, will going to transfer onto the nitrogen. Okay, so here you can observe here that group which is anti to this OH in ketoxime is going to rearrange, or you can say is going to transfer onto the nitrogen. Okay, in your GPAT examination they will simply give you some, you can say, groups here in place of this R and R dash, like any other alkyl or aromatic group, and they will simply ask you for the product, or they may give you a kind of similar groups R and R dash. If they are giving you a different groups, they definitely give you in the form of the this form, right? Because they have to check that whether you know or not that this R dash group, or you can say that the group which is anti to the OH is going to transfer on the nitrogen. So remember that the group which is anti to this OH is going to transfer on the nitrogen, or you can say rearrangement of that group going to take place, and it will form the substituted amide. Okay, in small separate lecture I will also upload some question which has been asked previously on in the GPAT examination from the Bachmann rearrangement, but this must be clear that this reaction simply involves the rearrangement of the ketoxime group, and that ketoxime group is formed from the ketone via with the reaction of the hydroxyl amine group. Okay, and how this rearrangement take place, we will see a very simple brief mechanism of this. Okay, so what happens as we are reacting it with the H plus, or you can say acid, this OH will donate the electron to this hydrogen, and it will give us a product like this. This hydrogen will attach here with the OH, and this oxygen will create a positive charge on the oxygen. Okay, it will create a positive charge on this oxygen. Now what happens in the second step, that as this oxygen is positively charged, so it's more electronegative, and as its valency is also not fulfilling, so this intermediate is unstable, and suddenly this bond is going to break, and this oxygen will take the electrons of this NO bond, or you can say nitrogen and oxygen bond, and this oxygen will take the electrons of that bond, and it will removed as a H2O. And simultaneously this R group is going to transfer here on this nitrogen, so it will create a compound like this. It will create a carbocation, and as here you can see that R dash group, which is I have previously mentioned that it is anti to the OH, is transferred on this nitrogen. And now the water molecule removed here is again going to attack on this carbocation, because as water can act as a Lewis base and acid bond, so it will act as a here a Lewis base. It will donate the electron to this carbocation, and it will form a compound like this. Now what happens that the one H plus will be removed from this OH2, so it will be OH, and the electrons of this bond is going to transfer on the nitrogen. Okay, and as this OH, as this is removed, you can say that this hydrogen is removed, so now it becomes OH is going to transfer the lone pair on this bond, and it will form a carbonyl bond, or you can say carbonyl group. And ultimately it will form the substituted amide. And as this H plus is removed here, it is also not going to wasted. This H plus is taken up by this nitrogen, or you can say that nitrogen will donate the electron to this hydrogen, and it will form a bond, and it was converted to NH. So here you can see that we are able to get a substituted amide product. Okay, so this one is the first reaction, that is Beckmann. Now we'll move to forward to the next reaction. So the next reaction which we are going to learn is Robinson annulation. So what happens in case of Robinson annulation is that first of all it is a combination of Michael addition as well as the aldol condensation. First step is Michael addition and second step is aldol condensation. Okay, so and generally it is given by the alpha beta unsaturated carbonyl compound reacting with the carbonyl compound. Remember it, alpha beta unsaturated carbonyl compound is reacting with the carbonyl compound, a simple carbonyl compound. For example, here we take one example of reaction which is a cyclohexanone reacting with a 1 alpha beta unsaturated carbonyl compound. Okay, this is 4 numbered aliphatic compound with double bond and containing the carbonyl group, So this is our alpha and this our is beta. Okay, so if you know the Michael addition, simultaneously I will also take the Michael addition in this Robinson annulation itself, so it will also get cleared. Okay, so what happens in case of Michael addition? The Michael addition actually also take place in the alpha beta unsaturated carbonyl compound, and one example of a drug also I will give you is warfarin. In the synthesis of the warfarin, also Michael addition take place. Okay, so remember that. In case of here, what happens in case of Michael addition? First, it will form a carboanion. So what happens that here there is one hydrogen. Okay, so what happens that this carbon hydrogen bond electron will be taken up by this carbon. Okay, and it will generate a carboanion. And now this carboanion will attack on the beta carbon, or you can say beta position of the alpha beta unsaturated carbonyl compound. Beta position of alpha beta unsaturated carbonyl compound, and this hydrogen which is get removed because this bond, the electron of this bond, as it is taken up by this oxygen carbon, so this hydrogen will be taken up by this alpha group. How? As here you can see that this carboanion have already attacked on this beta position of the alpha beta unsaturated carbonyl compound. यहाँ पे बीटा पोजीशन पे ये कार्बोएनायन अटैक कर चुका है. So this double bond electron will be donated to this hydrogen. Okay, and you can see that the intermediate like this will be created, or you can say it is also a stable compound. Okay, intermediate like this. Okay, this will be formed. So this first reaction is a Michael addition. Okay, so this first reaction is Michael addition. The first step is Michael addition. What happens that this will create, first this cyclohexanone will create, or this will create a uh, carboanion, and this carboanion will attack on the beta position of the alpha beta unsaturated carbonyl compound, beta position of the alpha beta unsaturated carbonyl compound, and then the electrons of this double bond will be transferred to this hydrogen, and this will form ultimately this compound. Okay, so this was first formed. Now next slide will take the formed compound. This compound here, if you see, so here we have a one alpha carbon here. If we enlarge that compound formed previously, so here we have a one alpha carbon, and if you know the requirement for the aldol condensation is a alpha carbon okay because that alpha carbon will contain alpha hydrogens. So what happens that, and this all will occur in a I am not having mentioned here the reagents, but reagents will be the basis, okay, which will attract the protons, or you can say they are act as a nucleophiles. For example, in presence of base like sodium, you can say ethanoate, or sorry, not sodium ethanoate, sodium ethoxide, or you can say CH2ONA, sorry, CH3CH2ONA, or CH3ONA. These are the strong bases, or you can say OCH3 minus, CH3CH2O minus, or you can say ethoxide ion, or uh, methoxide ion, which is CH3O minus, or CH, or you can say C2H5O minus. Okay, this kind of bases are involved as a reagent, which will take from through which the reaction will be take place. Okay, so what, this is the main thing. Now these are the reagents, remember this. This everything will not take place by this. It's require, obviously it's a chemical reaction, so it requires some energy or some temperature, pressure, and this reagents also, okay, and this reagents also required to form a product from the Robinson annulation. Okay, now as I have mentioned that in case of second step is aldol condensation. So what happens in case of aldol condensation is that here you can observe here one alpha carbon is there, and as you know, in case of you can say aldol condensation, there also a formation of carboanion. So what happens that electrons of this hydrogen or any of this bond which is formed with the carbon by the hydrogen will be taken up by the carbon, okay, and it will forms a carboanion, same as in case of Michael addition. And it will create here a CH2 minus, okay. Now what happens, this is the intermediate. Now this is unstable compound, so what happens here, this carbonyl group, the double bond between the carbon and oxygen, the electrons of this double bond is going to transfer on this oxygen because of its electronegativity, and at the same time as this will create a partial positive charge on this carbon, right? So this is a nucleophile CH2 minus, this will attack on this carbonyl carbon, and it will form a compound like this. As I have showed that this oxygen have taken this electron, so it is created here O minus, and here this CH2 which is in the form of CH2 minus is now attached with this carbonyl, this carbon here at this junction of this ring, this one I have rounded here, is attached with that carbon. So if you observe, so this is a ring formed here and this four carbons 1 2 3 and 4 is here. This is first, this second, third, and fourth. So you can see that ring is formed here via this attack of this CH2 minus on this carbonyl group. Okay, and the final step which is taken place is here the H plus which is removed here. In remember, in chemistry nothing is going to waste. So this hydrogen which is removed earlier, now this OH minus will donate the electrons to this hydrogen because it's having a already a one lone pair extra. Okay, so it will donate that electron to that hydrogen and it will form a compound like this. So here it is OH, and the final step which is taken place, if you know the aldol condensation, in case of aldol condensation same the hydroxyl group is created and then that hydroxyl group will undergo the dehydration. Okay, or this formed compound undergo dehydration by removing the hydrogen from the adjacent carbon to the, or you can say neighboring carbon to this OH. So neighboring carbon is this one which I have rounded here. So this what this OH and this hydrogen is going to remove in the form of water, and this will ultimately form the final compound, which is look like this. Okay, so this one is your final compound. Why I have explained this in that this much detail, because mostly they sometimes ask you a product. They will give you a some XYZ compound, which is mostly obviously the alpha beta unsaturated carbonyl compound and one carbonyl compound, and they will tell you that what will be the product of this, and they may also tell you that what will be the product of this reaction by the Robinson annulation reaction. Okay, so that's why I have explained you this in much detail. Now in simple reaction, if you show it, so there is a simple reaction that this is a carbonyl compound, but remember that the carbonyl compound will be mostly already having a one ring, or you can say it's a acyclic carbonyl compound, or alicyclic, not acyclic, sorry, it's alicyclic carbonyl compound which is already contain a one ring. Okay, and there is a one alpha beta unsaturated carbonyl compound. And this one is going to form a in presence of base. Okay, as I have mentioned, base in the sense of Lewis base. Okay, not that base, is in the sense of Lewis base, remember that. And this will ultimately form a this compound. Okay, which I have shown you via the mechanism that how this compound is going to form. Okay, so if you observe that the one ring is created here, and that's why it's called as Robinson annulation, and it, as I have mentioned, is a combination of Michael addition as well as the aldol condensation. Okay, and why here this double bond is created? Because of the dehydration take place, if you know, in the case of aldol condensation. Okay, so this one is the second reaction, naming reaction, which we have covered, which is aldol which is Robinson annulation, and first one was Bachmann rearrangement. Now, now in for other reactions, I am not going to cover the reaction mechanisms because they are mostly asked directly the reactions. Why I have taken up the mechanisms in case of Robinson annulation and Bachmann rearrangement, because they are asking you to form a product from the any compound, right? It will not be directly from the book. So that's why the reaction mechanism understanding is required for that both of the reactions. So that's why I have taught you in the much detail. Now the next reaction, naming reaction, is Dakin Dakin reaction. So what happens in case of Dakin reaction is that it is simply a aromatic ketonic compound. Okay, aromatic ketonic compound is react with react with the H2O2, okay, as a reagent, and it will convert it into the, so you can say that it's a very simple oxidation reaction, and it will create the COOH group here. So it will create a benzoic acid, you can say, and it will also create one aliphatic carboxylic acid compound. Okay, so what you have to remember is that in case of Dakin reaction, the carboxylic acid, or you can say benzoic acid, is going to form, that you have to remember, and it's a simple oxidation reaction taken place in the presence of hydrogen peroxide. Okay, so good evening everyone. This is a continuation of the previous video, and in this video we are also going to understand and learn some more important organic chemistry naming reaction which are asked in the GPAT as well as the NIPER examination. So the first reaction which we are going to take is Schmidt rearrangement. Okay, it's a Smith rearrangement. So in case of Smith rearrangement, it is also a same as in case of Bachmann rearrangement. If you one thing which I want to mention, in GPAT and NIPER examination and any other pharma competitive examination, they are also asking you mostly in GPAT and NIPER, not other, because that much high level question they may not ask. What they ask you is that in which rearrangement reaction the transfer of the group take place on the nitrogen. So your answer could be, or if I clear you on that, that the reactions in which that transfer of the group, whether it's alkyl or maybe aromatic, we are going to see the aromatic group in case of Smith rearrangement. So whether it's alkyl or aromatic group, is going to transfer on the, if it is nitrogen, so which reaction is there, कौन सी ऐसी reactions है कि जिसमें नाइट्रोजन पे जो है वो ट्रांसफर होता है ग्रुप का. So that reaction are one is Smith rearrangement, right? One is Smith rearrangement. ओके कि जिसमें नाइट्रोजन पे ट्रांसफर होता है ग्रुप का. ओके, स्मिथ रीअरेंजमेंट इज देयर, देन देयर इज ए बैकमैन rearrangement is there, then there is a Curtius reaction. If you know, acyl azide is the starting material. If you know about the Curtius reaction, that is also we are going to take. So in case of Curtius reaction, it involves the acyl azide. Then if you know Hoffman bromamide degradation, right? Hoffman degradation of amide, if you know, it is also known as Hoffman degradation or Hoffman degradation of amide. There is a formation of amine take place. So in case of Hoffman degradation, in case of Hoffman degradation, it involves the amide group converted into the amine. Same here in the case of Smith rearrangement also, that it also involves the formation of primary amine, and here also it involves the formation of primary amine, but with the one less carbon. Okay, with the one less carbon in case of Hoffman degradation or Hoffman bromamide degradation, or you can say Hoffman degradation of amides, which will gives you amine. Okay, so these are the name of the reaction. ये वो reactions हैं जिनके केस में जो नाइट्रोजन है उसके ऊपर जो है वो ग्रुप का रीअरेंजमेंट होता है, जैसे कि हमने लास्ट बैकमैन रीअरेंजमेंट में देखा कि जो आर डैश ग्रुप था और ग्रुप जो कि Nt2OH था, वो जो है वो नाइट्रोजन के ऊपर ट्रांसफर हो रहा है. सेम अभी हम स्मिथ रीअरेंजमेंट में देखेंगे, ऐसा ही कर्टियस रिएक्शन में भी होता है, एंड सेम ऑल्सो अकर्स इन द हॉफमैन डिग्रेडेशन. सो दिस विल बी आस्क्ड इनटू द MCQ. And one more thing which I am going to clear, they may ask you that there are some reaction also कि जिसके केस में ऑक्सीजन के ऊपर ग्रुप ट्रांसफर होता है, राइट? ग्रुप ट्रांसफर्ड ऑन टू द ऑक्सीजन. ओके, ऑक्सीजन के ऊपर ग्रुप ट्रांसफर होता है. सॉरी, जस्ट इट्स ड्रॉन wrongly. सो ऑक्सीजन के ऊपर जो है वो ग्रुप ट्रांसफर होता है. सो विच काइंड ऑफ रिएक्शन इन्वॉल्व्स जिसमें ऑक्सीजन के ऊपर ग्रुप ट्रांसफर होता है. सो दैट रिएक्शन इज वन रिएक्शन ओनली, विच इज बेयर Villiger reaction. Okay, it is very important. Bayer-Villiger reaction. Now we continue with our we are continue with our Smith rearrangement. So what happens in case of Smith rearrangement? So what happens in case of Smith rearrangement is that there is a carboxylic aromatic carboxylic compound. For example, you can say a benzoic acid. Okay, it is going to react with the N3 minus group, or you can say it look like this. And if you know the name of this compound, so it is known as azide. Okay, and as I have previously mentioned also, that in case of Curtius reaction it involves the acyl azide, and here only the azide is involved. Okay, and name of this one you already know, which is aromatic carboxylic acid, and it will simply gives you a primary amine. It gives you a first degree amine or primary amine. So here also what happens, that the the OH group of this carboxylic acid, okay, will take this electron from the CO bond, or COH bond is there in carboxylic acid. Okay, so this bond electron is going to taken up by this OH, and this OH will be removed in the form of OH minus, and this NH minus will attack here, and it will form a compound like this. Okay, so it will form a compound like this. Now as you can see that here this nitrogen is having a 4 bonds, so it's more electronegative compared to this nitrogen, sorry, compared to this nitrogen we have rounded. So this bond electron will be transferred on this N plus, and it will be removed in the form of N2. okay, N2 के फॉर्म में वो निकल जाएगा. And now what happens, that this aromatic group, okay, this aromatic group will transfer on this nitrogen. So as I have mentioned earlier, that here also the group transfer take place on the nitrogen. Okay, and then with the steps, if we move forward more, so ultimately it forms a compound like this if you observed it properly. Sorry, just, and it will form a compound like this. Okay, so here you can see that valency is satisfied, because what happens that this entire group, this one, is going under rearrangement, and it form the group like this. As you can see that this NH, this NH is attached with now this aromatic group. Okay, and now this will react with the you can say a base, which is NaHCO3, and then it will converted into the primary amine, which is primary aromatic amine. Okay, and CO2 also removed. I am not going into that much detail of the reaction mechanism, because I think it's not necessary in this case. Simply you can just identify this Smith rearrangement by observing the azide and also the carboxylic. Sometimes here they are also giving you a ketone, so be careful. But what you have to see is the azide. Okay, whether it's a carboxylic acid or it's ketone, but when it reacted with the azide, okay, so it will gives you a primary amine. So this is the Smith rearrangement. Now the next reaction which we are going to take is Itard reaction. This reaction was asked in the NIPER JEE 2023 also, which is Itard reaction. So now in Itard reaction, what simply happens is that in case of Itard reaction, the toluene, right, this is toluene. This toluene is going to converted into the benzaldehyde. In presence of chromyl chloride. Okay, I am just arrowing down here. In presence of chromyl chloride. Okay, in presence of chromyl chloride, it will gives you a benzaldehyde. This is simply a Itard reaction. The next reaction which we are going to take is the Hunsdaker reaction. So what happens in case of Hunsdaker reaction is so in case of Hunsdaker reaction, there is a salt of, or you can say silver salt, silver salt of the carboxylic acid, okay, C double O minus and Ag plus, is going to converted to the bromobenzene, and also it removes the CO2 group, and also AgBr. And the reagent involved is carbon disulfide and CCl4. Okay, So you have to remember, in case of Hans-Decker reaction, it involves the conversion of the salt of the carboxylic acid, whether maybe it's aromatic or aliphatic, is going to convert, mostly it is aromatic, so it is going to convert it into the halide form, or you can say a halide substituent, which is bromine. In this case it's bromine, so it's bromobenzene. And here, yeah, also it's in presence of bromine. You may think that आपको ऐसा लग रहा होगा कि bromine कैसे आ गया, but bromine is also there, so it's react with the bromine, and then it's converted into the bromobenzene, removes the CO2. And here it's a very simple maths, or this reaction is taken at a somewhat higher temperature. So as you know that this group, this COO group, is going to remove in the form of CO2. Okay, then this Ag plus will be, one bromine will react with the Ag plus and AgBr, it convert into the AgBr, and this one bromine is going to attach with the benzene ring, and it's form the bromobenzene. Okay, so this is Hans-Decker reaction. Now the next reaction which we are going to taken up is Bamford-Stevens reaction. Okay, so what happens in case of Bamford-Stevens reaction? So if you know the Hinsberg reagent, so a similar kind of reagent, I'm giving you the IUPAC name also. So this is paratolyle, this one is sulfonyl paratolyle sulfonamide, you can say it's similar to amide or sulfonamine, so it's a very similar group to the Hinsberg reagent. If you know, in case of amine identification, the Hinsberg group is used, or you can say Hinsberg reagent, which is benzene sulfonyl chloride. And if you know that in case of nowadays, in case of Hinsberg, is in place of Hinsberg reagent, somewhat it's modified version, which is paratolyle benzene sulfonyl chloride is used. Okay, so it's very similar to that if you observed it. Okay, and it also contain a doubly bonded. Okay, so what happens in this reaction? Simply, in presence of base like you can say NaOCH3, as I have mentioned in one more previous reaction, which is maybe a Robinson annulation, right? So same thing take place here. In presence of base, rearrangement take places, and this bond is going to break between this uh, between the, you can say, carbon and nitrogen. The double bond between the nitrogen and carbon is going to break, and it will convert into the alkene. Okay, it is going to convert into the alkene. And one more thing, that one of this R2 group, or you can say R dash group, is going to transfer on this CH group. Okay, and it will, or you can say I will show you the final product so you will get idea. Okay, So this is the final product, which is alkene. So what you have to remember in case of Bamford-Stevens reaction is that there is a paratollyl reagent which is going to undergo rearrangement reaction in presence of the base, and it is going to convert it into the alkene. Okay, so this is the Bamford-Stevens reaction. Okay, the formation of alkene take place from the paratollyl reagent. Okay. The next reaction which we are going to take is Baeyer-Villiger reaction. Okay, so just a moment. So what happens in case of Baeyer-Villiger reaction? First I will just write the name. Maybe in previous slide I have mentioned here maybe a W, so just avoid some spelling mistakes are there, so just avoid it. Okay, so Baeyer-Villiger reaction. As I have previously mentioned, in the Baeyer-Villiger reaction, it involves the transfer of the group on the oxygen. Okay, transfer of the group on the oxygen take place in case of Baeyer-Villiger reaction, and it is a reaction between ketone and the per acid. Okay, you know about per acid, may or may not. uh, this is per acid, if you know. If you know the structure of hydrogen peroxide, so here this is because of this two oxygen simultaneously attached, this is known as per acid. In case of carboxylic acid it is COOH. In case of per acid it is C triple OH, you can say, if you write it in a molecular form. Okay, in a molecular formula, so it's a C triple OH. Okay, so that is the difference. So this is per acid and this is ketone, and this will going to give you a ester compound. Okay, is going to give you a ester compound. This both group are similar mostly, so that's why I've just written here R. Okay, so this is ester is formed. So what you have to simply remember in case of Baeyer-Villiger reaction is that it is a reaction between the ketone and per acid, and it will give you a ester compound. Okay, in case of Baeyer-Villiger reaction. Okay, I think hope you clear that it's very simple reaction between the per acid and ketone. Now the next some important oxidation reactions, you can say, which we are going to take up is open air oxidation and simultaneously the MPV reduction, because these both are very important. Okay, so first is open air oxidation, and then there is a MPV reduction. Okay, just a moment. So this is open air oxidation, and the MPV reduction, which is Parvi-Verley reduction. Both I am going to take place in I will take it in a simultaneous way. So the first one I am going to take is open air oxidation. What happens in case of open air oxidation is that the secondary you can say alcohol or 2-degree alcohol, this is 2-degree alcohol. Two-degree alcohol is going to convert into the ketone. Okay, and it is in presence of aluminium tertiary butoxide. It's written as aluminium tert butoxide, or you can say aluminium, I will just write it as tertiary butoxide so it will helpful for you. Tertiary butoxide. Okay, aluminium tertiary butoxide. This is open air oxidation. The reverse of open air oxidation is MPV reduction, which is conversion of the ketone into the 2-degree alcohol. If you know that, अगर आपको पता है कि जब अल्कोहल का हम ऑक्सीडेशन करते हैं 2-डिग्री अल्कोहल का, तो वो हमें देता है कीटोन. और अगर हम प्राइमरी अल्कोहल हो, अगर 1-डिग्री अल्कोहल अगर हम उसका ऑक्सीडेशन करते हैं तो वो हमें देता है अल्डिहाइड, जैसे कि CH3OH. ओके, CH3OH विच इज मिथेनॉल. मिथेनॉल का अगर आप ऑक्सीडेशन करेंगे तो वो आपको देगा फॉर्माल्डिहाइड विच इज HCHO. वैसे ही अगर आप 2-डिग्री अल्कोहल का एग्जांपल जैसे कि आइसोप्रोपाइल अल्कोहल, ओके, विच इज प्रोपेन-2-ऑल, उसका अगर आप ऑक्सीडेशन करेंगे तो वो आपको देगा कीटोन, राइट, प्रोपेनॉन यू कैन से, और एसीटोन. सेम वे इफ यू अगर एसीटोन जो है, प्रोपेनॉन जो है, उसका पर आप एमपीवी रिडक्शन करोगे विच इज मेरविन पॉन्ड्रॉफ वेरली रिडक्शन. मेरविन पॉन्ड्रॉफ वेरली reduction, MPV reduction, it is known as simply, I have written just R here for the reduction, okay, or I just write read N, which is a short form of reduction. So in MPV reduction, this ketone is going to convert into the again 2-degree alcohol. So that's why it's reverse of the open air oxidation. And here the reagent is aluminium iso propoxide. Okay, so this is the simple conversion. In press there is the aluminium tertiary butoxide and here is a aluminium isopropoxide. Okay, so these are some naming reaction from the my side. If needed, still I will take some more naming reaction, but we will keep it up to this. If Payam sir is going to take your another remaining naming reaction, then there is no problem. If he is not going to take that naming reaction, I will discuss with him So then I will take some more naming reaction, so it will helpful for you to solve the questions. And thank you to watch this video, and hope you all will come up with come up with watching the video. Okay, and you can ask your question into the our live classes. Okay, any questions you feel from this any of this naming reaction, you can ask. So thank you very much.